Assalamu alaikum, welcome back everyone, chapter 38 of the Arduino series. In this video I'm going to be covering a RFID module called RC522, and the example I'm going to be demonstrating is going to allow the PICC with the correct UID to turn on the green LED, and an unrecognized UID is going to turn on the red LED. Now at the bare minimum, you're going to need the breadboard, you're going to need the Arduino 7 male-to-male jumper wires. I'm using an RFID module called RC522, and you're going to need some PICC. I've lost my blue tag that comes with it, however I do have 3 different cards. If you want to follow with me on the project, you're going to need 2 resistors, 2 LEDs, and 4 male-to-male jumper wires. Now, the way the RFID module works is that it transmits a signal using radio frequency that is picked up by either the card or the tag, whichever one is within proximity. This induces a current within the PICC, which causes it to transmit its own radio frequency, and by doing so transferring the data stored within. And this is picked up by the antenna on the RFID module. Now taking a look at the module, you find that you have 8 total pins. However, out of the 8 we're going to be using the 7, and the one we're not going to be using is the RQ pin. It serves no function for us, and we're going to connect the rest instead. The RC522 module is powered by 3.3 volts, and we're going to connect that from the Arduino to the first pin from the left. The RST pin on the module is going to be connected to pin 9 on the Arduino. The third pin is the ground pin, and we're going to ground the RFID module. Now onto the right side, the SDA pin, the first to the right, is going to be connected to pin 10. The SCK pin, the second to the right, is going to be connected to pin 13 on the Arduino, followed by the MOSO and MISO pins. They're going to be connected to pin 11 and pin 12 on the Arduino. And the way the pins are connected is due to the library that we're going to be using. And if you wish to follow my arrangement, the green LED is going to be connected to pin 4 and the red LED is going to be connected to pin 5. The first 2 lines contains 2 libraries. The SPI library comes pre-installed with the Arduino software, but the MFRC library has to be installed, and to do so you want to go into your Arduino software, click on Sketch, Include Library, Manage Libraries. You want to wait for the tab to open up, and once it's opened you want to type in MFRC-522, and you want to scroll to the one that says by GitHub Community, and you want to install it. Once you've finished including the libraries, we want to move on to the variables. In order to use the library, we have to tell the Arduino where we connected the SDA pin and the RST pin, and I simply do this by using #define and associating each value to each variable. Next, I make 2 integer variables for the 2 LED pins. I make a boolean variable called accepted, and I make it equal to 0. I'm going to later use this to determine whether the Arduino accepted the UID I presented from the PICC or not. And I make another integer value which I don't define, which is going to make sense later on. I make another variable called rows, which has the data type of byte, and the one that follows after it is going to be an array. Now the purpose of the array is to store the UID values of the card or the tags, and I will explain how to obtain that in a bit. And finally, I make a variable for the RFID pin in itself, which begins by writing all in caps MFRC522, and you want to give it a name. I just called it RC522. Within the parentheses, you want to write in the location of the SDA pin, and following it is the pin for the RST pin. Now, in order to get the UID of your card or your tag, you can use the example that's already provided by going into File, Examples. You want to scroll down all the way until you find MFRC522, and you want to go into something called Dump Info. However, I did go through the code and modified it a little bit just so that it's a little bit more clear, which you will be able to access in my Discord linked in the description. Once you finish connecting the RFID to the Arduino, you want to go to your tools, you want to go to your board and your port, and then you want to upload it. Open up the serial monitor, and then you want to wait for the text to appear. Once that's done, you want to use your PICC and quickly tap onto the RFID module. Depending on how long, you might see a series of timed out in communication, but we're not interested in that. You want to look at the start of the information and look for something called the card UID, and I would assume this is going to be different to you, so you want to copy yours, and then you want to paste it within the array. Make sure that it's between curly brackets. Between every column you want to add a comma, and because this is a hexadecimal value, you have to add 0x before it. And if you're using multiple UIDs like me, just make sure between every 2 lines you add a comma. And regarding the array, since I'm using 2 values, it's going to be regarded as a 2D array. However, since I don't have a set value because I may choose to add more UIDs, I have not put a value for the x-axis. However, since there's 4 columns on the y-axis, I've put 4. You have to keep in mind, in some cases the PICCs may be different in the sense that they may have more than just 4. And I've chosen to name the array unique ID. In the void setup, I start off by activating the serial monitor using the command serial.begin with the baud rate of 9600. Next, I have to activate the SPI library by using the command SPI all in caps .begin. I also have to activate the RFID module by using the command, the name of the RFID module I gave it, rc522.pcd all in uppercase _init with an uppercase I. I told the Arduino I want the text scan PICC to be presented on the serial monitor, and to finish off with the void setup, I told the Arduino that the red pin and the green pin are both going to be outputs. In the void loop, I use 2 if statements that resemble each other, and the first one, .pic_ is new card present, is used to determine whether a signal is being emitted from a tag or a card, And the second one, .picc_read card serial, is used to collect the data from the signal. They both have the return statement within the curly brackets, meaning that they will continuously loop. And if you notice the statement within the parentheses, that there's an exclamation mark, meaning that it will continuously loop until a card is read. Now the function of the for loop is for the Arduino to go through all the rows of the array. For the statement within the parentheses, I tell the Arduino that rows is going to be equal to 0, and if rows is less than 2, then add 1 by using the command rows plus plus. This will add 1 every single time. And I made it equal to 0 at the start and not equal to 1 because of the way the Arduino count rows. It starts from 0, 1, so the first row is counted as 0, and then the second row is counted as 1. Within the for statement, there's an if statement, and because of the limitation of how you can compare arrays, and I designed the comparison in such a way that the Arduino will compare the first quarter of the code received from the signal with the first quarter of the row, and the first column is labeled as 0, so it goes from 0, 1, 2, 3. And the UID received from the signal emitted from either the tag or the card is also received in an array, meaning that I can break it up in chunks, and it's stored within the command .uid byte. And I repeat this 4 times so I can compare all the columns. And if this ends up being true, I told the Arduino that the variable accepted is going to be equal to 1. And using another if statement, I say that if the variable accepted is equal to 1, then the variable n will receive a value of 1. And outside the for loop, I use another if statement, and he has the condition that if n is bigger than 0, and it can only be bigger than 0 if a UID is recognized, then present the text access granted onto the serial monitor, and to turn the green LED high and the red LED low. And I also use an if statement to say the opposite, where the UID of the tag or card that I'm using is not recognized, then to present the text access denied on the serial monitor, and to turn the red LED high and the green LED off. And at the end of both the if statement and else statement, I make n equal to 0 so I can reset the process so that I can detect another card. And the final command .picc_halt A is used as a delay command, which only allows the code to run again once a signal is detected. Now you want to have your Arduino connected, you want to go to your tools, and you make sure that your board and your port are connected properly. And then you want to open up the serial monitor. Now for me, I have 3 different RFID cards, 2 of which are the same type and can be read by the module, since the module can't read every single type of PICC card. And I put the values of the UIDs of these 2 cards within the array. And I made a third one as a random. However, my transportation card cannot be read by the module, and so I don't have access to the UID of it. And once I bring the card close to the module, it should present to me access denied. But if I use the 2 cards that I know the UIDs for and I have them registered within the array, they both will give me access granted. And if the video has helped you out in any way, consider giving it a like. And if you wish to get closer to the community that I'm trying to build, my Discord is going to be linked in the description, where you can ask me questions regarding anything you're not sure about, or you can access the codes that I've been using throughout this video.